get started. So at this point, I feel like it's been a minute. It really has though, because Monday we did Star 360. Yesterday there was no school. So last week, what we had looked at was how you solve systems of equations. We learned 3 different ways to solve. Those 3 ways were...
I know it. It's elimination, substitution, graphing.
Nice. So elimination, substitution, and graphing. We looked with the graphing already at some word problems and how you can use systems and graphing systems to help you answer these word problems. We're coming back to that today, but now we're going to use those other 2 ways to help us out. So the, what you just said, substitution and elimination. So the objective for today is I can represent word problems with systems of equations and interpret their solutions. So with that, I'll give you a second and then we'll get started.
Okay.
So the first one we're going to look at says the sum of 2 numbers is 40. The difference of those 2 numbers is 16. And the first part of this question is asking us to write a system. We learned as well, I'm just going to review. When you see the word system means...
A group of like equations.
Yep, or multiple equations. So we know we're going to be able to take this information and get multiple equations out of it. The first line says the sum of 2 numbers is 40. In order to know what that means, we need to know the word sum means...
Addition.
Yep. So it's saying when you add those 2 numbers, you get 40. From that information, we can get our first equation. What would that first one look like?
Could be like, I don't know, like 16 plus 24.
So you're coming up with, yes, you gave me 2 numbers, give us 40. Do you know those 2 numbers are 16 and 24?
No, so it'd be x plus y equals 40.
X plus y equals 40. I like how you're already thinking the 16 and 24 could give us 40, but since we don't know them, we'll use x and y. And I'm just going to write off to the side x and y are 2 unknown numbers, just to define our variable. The second one says the difference of those 2 numbers is 16. What is that saying?
Division.
Not division.
Oh, so subtraction.
Yep. If I asked you, like, what's the difference in our ages, you would have to subtract to figure that out. So difference is subtract. So it's saying when we subtract those 2 numbers, it equals 16. From that information,
Bx minus y equals 16.
Yep. So we could also, like you had said, a possibility for here is 16 and 24. Would that give us a difference of 16? No. So you've already figured out that would be something that satisfies this first equation, but not the second equation. That leads nicely into these next couple questions we've got, which are just like discussion questions, to talk through what this means here. So I'm going to relocate our system up here. X plus y equals 40, and x minus y equals 16. So these next couple questions here, we can talk through. You don't have to worry about writing anything on your paper. The first one says, in this situation, what do the solutions for this first equation mean? If it's a solution for this first equation, what does that mean?
It means you put 2 numbers in there to equal 40.
Yep. So for example, 16 and 24 would be 40. It's a combination of numbers that add and give you 40. If it is a solution for the second equation, what does that mean?
It means number minus a number equals 16.
Mm-hmm. So for each equation, each separate equation, how many possible solutions are there? For this first equation here, how many possible solutions are there for that?
Infinite.
Nice, math word, infinite. How do you know there's infinitely many?
Because you said, or because I don't know, you just keep going like another direction, and you can still get a number that would equal 40.
So the one you had started us with a moment ago, you said 24 and 16. When you say you can keep going in either direction, what do you mean?
It's like you could do negative 1,000 plus 1,040.
Ooh.
That equal 40.
So negative 1,000, and you said 1,040. So you can start with numbers that are really close, but then you can keep making them further and further apart. I like how you knew too that it can be negative. Some people look at this and they go 1 and 39, 0 and 40. That's as far as it goes. But you're right, it said nothing about them having to be positive. Same question for the second equation. How many possible solutions are there?
Infinitely many.
Yeah, same idea. There, you can keep going further and farther apart. When we're talking about a solution for the system, how many possible solutions for the system are there?
1.
Why is there only one possible solution for the entire system?
Because there's only 2 numbers that you can add together to equal 40 that you could also subtract to equal 16.
Yeah. So there's thousands, more than thousands. I was looking at this. There's infinitely many solutions for this first one, infinitely many solutions for the second one, but you hit the nail on the head. There's only one magical combination of numbers that will add to 40 and subtract to 16, which is what we are trying to find here. Nicely done. So you can probably guess then, we have come to the part where you are actually going to find what those numbers are. So we are going to solve this system of equations. We've got the system here. You had mentioned earlier there's 3 different ways you can solve. Looking at this system, which method do you want to use to solve it?
I guess addition. Well. I guess elimination.
Both answers are right. You're saying elimination. You specifically want to use addition. When we add those equations together, what does that give us?
Would be nothing equals 24.
So I heard nothing equals 24. Talk me through where those numbers are coming from.
Because if you're eliminating,
Mm-hmm.
oh wait, so it would be 2x
Okay.
equals 24.
Okay, so we've changed it. Nope, not that one. 2x, where's the 2x coming from?
X plus x.
Okay, so I'm just going to change the color. Here we go. So the x plus x gives us the 2x. What's happening to y?
It's eliminating.
Yeah, y minus y is 0 equals, how are you getting 24?
40 minus 16 would be 24.
40 minus 16? Where's the minus sign coming from?
Oh wait, so no, it would be 56.
Yeah, 40 plus our 16 gives us 56. So we get 2x equals 56.
Then divide both by 2.
Mm-hmm.
It would be x equals 28.
Nice mental math. Yep. 28. What did we figure out right there?
X.
And what's x represent?
One of the numbers that you can add with another number to equal 40 or minus with a number to equal 16.
Yep. So we figured out one of those two numbers is 28. To find the other number?
You can plug 28 into either of the equations.
Yep. Which one do you want to do?
The second one.
Okay. So if I substitute in the second equation, it's going to say
28 minus y equals 16.
Mm-hmm.
Then you subtract 28 on both sides. And 16 minus 28 is negative 12. No. Yeah.
Yep,
Yeah.
you're right. Negative 12. over here?
And so minus y.
Uh-huh. Yep, because you don't want to forget that negative sign. So negative y equals negative 12.
And then you divide both sides by negative 1.
Yep.
Negative 12 divided by negative 1 equals positive 12.
Yep. At this point, I like how you're showing me how you're getting your answer. This point, I think if you know that negative y equals negative 12, that means positive y equals positive 12. Feel free to just jump down to that. And this one here represents,
Which you can add with 28 to equal 40 or subtract from 28 to equal 16.
yep. And if you're able to do that, which I think you do a really great job of, is immediately knowing what this represents in the problem. What you just said, though, is exactly how we could check it. You said this is the number that we should be able to add to 28 to give us 40. Is that true? Does it add? And then you said this should be the number we can subtract to give you 16. Is that true?
Yes.
Yep. So we figured it out. And you've already told me the second part. What does your solution represent in this situation? This right here represents the combination of numbers that add to 40 and subtract to 16. The one thing that's different when we're talking about word problems in your solution, we used x and y. You can use any numbers you want. But the solution here isn't going to be a point. So when I write my solution, I'm not going to write 28, 12, because we're not talking about a point on a graph anymore. We're just talking about two numbers. So when I answer the question, I could just say something like the two numbers are 28 and 12. Depending on what the situation is, the words will change, obviously, but we are not going to write it as a point because we're not talking about a point on a graph. You feel good? I think you did great.
Yes.
I do have the picture of the graph to go with all of this. In this graph, we've got two lines. Let's start with this blue line here. I've labeled it for us. That blue line is that first equation you wrote. For it to be a point on this line, what do all of these points on the line represent?
What of the numbers can be?
What the numbers can be to
Equal 40.
Yeah. If it's a point on this line, these are all the different combinations of numbers that give us 40. So you had said earlier there are infinitely many solutions for this single equation. This line goes on forever because there's infinitely many points on that line. Any point on the line. So for example, that point right there is a combination of numbers that would give you 40. No, what's going on here? I labeled them both the same thing. Well, that's not right. Which one? Okay. This one is this equation. And I know that because that point I chose, what are the numbers at that point?
0.
Is 0 the x or the y?
Or no, so it's 16 and 0.
Nice. Each of these is 2, so 10, 12, 14, 16. 0, which is how I knew something was wrong because that does not add to 40. But any point on this line would be a pair of numbers that subtracts to give you 16. Any point on this line here?
You could add to get 40.
Yep. So for example, this point right here is at 20. That adds to give you 40. And then this one point right here.
You can add to get 40. It's,
Mhm.
yeah.
You can add to get 40 and you can subtract to get the
Yeah.
16. It's putting everything we've talked about together. I love lessons like this that put like all these different pieces we've learned all together in one single problem. There is one for you to try. The description of the numbers gets a little more fun, but the idea will be similar to what we just did. Okay? You want to try it?
Alrighty.
You see where we're at? It should be, yeah, down there. Nice. Mm-hmm. Mm. There it is. When you went from this line to this line here, explain to me what you did.
Oh. So that should be, or well,
Just tell me first how you got from this line to this line.
so if you distribute,
Mm-hmm.
it would be 3x, because 3 times 1,
Mm-hmm.
and then same thing, 3y. Okay.
There you go. Usually that's all it takes, is just asking, explain to me what you did. And you've got the right idea with subtracting it, but now it'll just be a different number. Uh-huh. Yep, you get it. Real quick, people at home, what Niall chose to do was multiply by that -3, which gives you -3x minus 3y equals -22.5. When you've got your 3x plus 4y equals 26, that's going to end up giving you y equals 3.5. And then I didn't even see any math. Did you do the second part in your head?
Yeah.
How'd you get x?
Because when you plug 3.5 into the second equation, it's just x plus 3.5 equals 7.5. If you subtract 3.5 from both sides, it gives you x equals 4.
Yep. So we're just using that fact that we know they add to 7.5. So if this one's 3.5, it sounds like you did a lot of that math in your head and you just said you knew the other one has to be 4. These first two systems here, even though they were word problems, were still math problems, right? Like we're still talking about like, oh, like 3 times the first number and 4 times the second number. The rest of these are going to be like more real world, where we're actually talking about things and not just 2 random numbers, x and y. So for this one here, we've got a teacher purchased 20 calculators and 10 measuring tapes for her class and paid $495. Later, she realized that she didn't order enough supplies. She placed another order of 8 of the same calculators and 1 more of the same measuring tape and paid $178.50. The system that represents the situation is below. And look, they've already given us a system here. The first question, similar to what we had done before, is what does the solutions to each equation represent? So this first one here, where did this equation come